fundamentals of bridge inspection. Has been inspection, equipment, and equipment necessities, standard tools for cleaning, inspection, visual aid, measuring, documentation, access, miscellaneous equipment, special equipment, survey equipment, and non-destructive testing equipment, underwater inspections equipment, other special equipment of recent development and equipment, rotary precision, scoring, measurement, scoring, monitoring, score watching, score monitoring, collar, remote camera, high-speed under clearance measurement system, robots, laser scanning, data record, hoarding, hardware and software, primary safety concerns. Alright, topic 3.4, inspection equipment. 3.4.1, equipment necessity. Several factors play a role with the type of equipment need for the inspection, bridge location. Type of the two main factors for determining equipment need for the bridge is located over the water. Certain pieces of the equipment, such as life jacket of the boats, are also important to have. Also, if the bridge is made of the timber, then specific pieces of the equipment like increments bore with the ice picks are needed, whereas they would not be necessary on a steel concrete bridge. Another factor influencing equipment needs to be the type of inspection. It's therefore important to review every facet about the bridge before beginning an inspection. A few minutes spent reviewing the bridge fails, making a list of the necessary equipment that can save hours of the wasted inspection time in the field following its inspectors do have the required equipment. Standard tools. In order to inspect for the performance adequate on comprehensive inspection, proper tools must be used. Standard tools that the inspector should have available on the bridge site can be grouped into 7 basic categories. Tools for cleaning, tools for inspection, tools for visual aid, tools for measuring, tools for documentation, tools for access, and miscellaneous equipment. Tools for cleaning, tools for inspection, tools for visual aid, tools for measurement. Alright, tools for cleaning include whisk broom used to remove loose dirt and debris, wire brush removing the loose paint and corrosion from steel elements, scrapers a 2-inch from removing corrosion and growth while elementing surfaces, flat blade screwdriver used for the general cleaning and probing, shovel used for removing the dirt and debris from bearing areas. Tools of inspection include pocket knife, usually general duty, ice pick used for surface examination of timber elements, hand brace and bits used for boring and suspecting areas of the timber elements, increment borer used in internal examination of timber elements, shipping hammer with a leather holder, a 16-ounce geologist pick used for loosening dirt, rust scale, sounding concrete, checking from shared and loose fasteners, plumb bomb used to measure vertical alignment in substructure or substructure. A superstructure or substructure element, tool belt with tool pouch used for convenient holding access to the small tools, chain drag used to identify area of delimitation of the concrete decks, range pole or probe used for the probing of the score holes. Tools for visual aid include binoculars used to prove areas prior to inspection activity for examination distance, flashlight used for illuminating dark areas, light magnifying area, glass, 5 power, 10 power used for close examination cracks, examining prone cracks, inspection mirrors used to inspect inaccessible areas, underside of deck joints, side penetrant used to identify cracks in their lengths. Tools for measuring include pocket tape, 6-foot rule used to measure defects and element joint dimension, 25 to 100-foot tape using measurement component dimension, calipers using measure the thickness of an element beyond an exposed edge, optical crack gouge used to precise measurement of crack width, paint film gauge used to check the painting thickness, telemeter protractor used to determine the tilting substructure, measuring angle bearing tilt, thermometer used to measuring ambient air temperature and substructure for the temperature, 4-foot carpenter level used to measuring the deck cross slopes and approaching pavement settlement, D-meter ultrasonic thickness gauge used to accurate measurement of steel thickness, electronic distance meter used to accurately measurement of the span length, clearance when access is a problem, line level and string line. Tools for documentation include inspection forms, clipboard, pencil, used record keeping for most of the bridges, field books used for additional record keeping the complex structure, straight edge used for the drawing concise sketches, 35mm camera used visual documentation of the bridge site and the condition, Polaroid camera used to provide instant documentation for serious conditions required immediate review by official personnel, digital camera used to provide digital images with effects which can be downloaded email for instant assessment, chalk and keel, paint sticks and markers used for the elements and effects with identification, improve the organization and photo documentation. Center punch used to applying reference marks to seal elements for movement documentation, bearing tilt and joint openings. P&K nails or Parker Kalon masonry survey screws used to establish a reference point necessary for the movement and documentation of substructure. The tools for access or some of your common tools are the access include ladders used for substructure, various areas, superstructure, boats used in surrounding inspection safety over waterwork, rope used to aid in climbing, waders used in shallow streams, tool access are described in further detail in topic 352. Miscellaneous equipment should include C-clamps used to provide a third hand when taking difficult measurements. The penetrating oil aids removal of the fastener, lock nuts, pin caps, and when necessary, inspect repellent, reduce attack by mosquitoes, tick, and chilgers. Wasp around hornet killer are used to eliminate nests and permit inspection. First aid kit used for small cuts, snake bites, bee stings, dust masks, and respirators. Respirators used to protect against inhalation in dusty conditions. Work around pigeon droppings. Coveralls used to protect the clothing and skin against sharp edge and while inspecting. Life jacket used in safety over water. Cell phone used to call in emergencies. Toilet paper used for other emergencies. Better safe than sorry. Alright, 343, special equipment. For the routine inspection common bridge, special equipment is usually not necessary. However, some of the restrictions, special inspection activities require special tools. Special activities are often subcontracted by agencies responsible for the bridge. Inspectors should be familiar with the special equipment and its application. Survey equipment, special equipment circumstances may require use of transit level, increment, rod, other survey equipment. The equipment that can be used with established components, the exact location relative to the other components, as well as the established reference point. Non-destructive testing equipment is in place. Examination and material of the structural integrity without damaging the material. The non-destructive equipment allows the inspector to see inside the bridge element and assess the deficiencies that may not be visible with the naked eye. Generally trained technicians necessary to conduct a non-destructive test and interpret their result. For more detailed description than destructive testing, refer to topics 13.1.2, 13.2.2, 13.3.2. Alright, underwater inspection equipment is examination of substructure units with a channel below the waterline, waterway, and shallow. The underwater inspection can be performed above the water. Simple probing can be performed using a range pole, piece of the reinforced steel, survey rod, folding rule, or even a tree limb. When the waterway is deep and an underwater inspection must be performed by a trained diver, this requires special diving equipment, including the work platform, fathometer, ground penetrating radar, air supply system, radio communication sign equipment. Refer to topic 11.3. More detailed description on underwater inspection equipment. Alright, other special equipment inspection may require special equipment to prepare the bridge prior to the inspection. Such special equipment includes air, water, jet equipment used in clean surfaces for the dirt and debris, sand, shot, blasting equipment used for clean steel surfaces of the bare metal, burning, drilling, grinding equipment. Our recent developments in equipment. In addition to standard special equipment listed previously, there are new equipment and technology available to aid bridge inspection. The developments various types of advanced techniques described in topics 13.1, 13.2, 13.3. The following information represents some of the advances of the inspection tool data collection. Alright, rotary percussion is a technique where the uniform tapping is produced by a rolling gear tooth wheel and determining the concrete defects that allow for the quicker inspection and overhead vertical surface similar to U with a chain drag with a horizontal surface. Advantages of the rotary percussion tool testing tools include the ability to detect near surface delaminations, quickness of testing, low equipment cost, and relatively low level user skill required low sensitivity to their surroundings. Show the rotary percussion. Alright, score measurement. The shift flow is a specialized device used to measure the depth of the scoring during the flood flows. And a consistent depth finder mounted on the water scale. The use of the water scale allows the depth of reading to be taken in extremely fast flowing water. It allows excellent maneuverability in the depth finder into locations under the bridge. Your score monitoring. Score Watch is a secure web-based bridge score monitoring software product that allows transportation engineers to predict, identify, prepare for, record potential destructive flooding events. Score Watch identifies the occurrence of a flood event, collects the process relevant bridge information, several sources of real-time hydrological, any bridge score monitoring device data. Transportation officials will be able to efficiently dispatch emergency personnel, bridge safety inspectors, maintenance workers before, during, and after the flood effects. Events affect state bridge inventory. Score Watch is designed to active, proactive bridge score monitoring system. Creates a list of score critical bridges experience with the respective critical event. Your score monitoring collar, a magnetic sliding collar. Use the score monitoring device. The magnetic sliding collar consists of a stainless steel pipe driven into the channel bottom. The sliding collar drops down to the end of the pipe. The score progresses. Location of the collar is detected in the magnetic field created by the magnets on the collar. Installation conducted with the cooperation state highway agencies. Demonstrated with a simple low-cost instrument with an adaptable various field situation can be installed with the equipment and technical skills normally available at the district level state highway agency. And it shows a scoring monitoring collar. Your instrument enclosure bridge jacks, flexible conduity, 1-inch UV resistant rubber hose, attached bridge cable conduity clamps or conduit can be routed to the backside of the pier with the debris with ice or air. Your pile distance varies magnetic sliding collar. Note install instrument upstream face and pier at location with a maximum score. Our remote camera, the basic component of the computer-based image system, include the imaging sensor, most commonly solidly stated camera, the image acquisition boards, which convert optical images into array digital information representing brightness value of the surface, and the dedicated processor of the computer-based imaging system can be provided with the two main types of information: spatial measurement, surface analysis. Spatial information encompasses the two-dimensional, three-dimensional analysis and measurement and recognition. Surface analysis provides information regarding the color and grayscale attributed to the target. For example, the image is size that is able to distinguish Fhwa with the rest of the surface, determine the size, shape, and location. Even the smallest color attributed to the fact of the field view can be processed within a fraction of a second, can be ordered in 200 to 500 times the size of the smallest feature of interest. Remote camera. Alright, high speed under clearance measurement system. The system can mount on any vehicle trailer hitch receiver system measuring underclearance of the bridge at normal highway speeds. Along with the underclearance data, the GPS information is gathered. Software is used for the data acquisition, display analysis of the bridge beam height is read to the nearest tenth of a foot. The GPS information can be pasted into a map program and obtain the structure location for the future reference. High-speed underclearance measurement system. Alright, robot devices have many applications being developed, and university research, high-level underwater bridge inspection are among these applications. One example, the serpentine robot being developed with the process of multiple joints, given the superior ability to flex, reach, and approach all points of the bridge. Robots under development. Other developments of the robotic device are discussed more in detail in 13.3. Alright, laser scanning. Laser scanning technology can create accurate, complete 3D built as models quickly, safely. These digital models are automatically combined with CAD design models to allow generation as built drawings of existing structure. The method can replace tedious field measurement rehabilitation projects. Alright, data recording hardware. Data recording hardware can include regular office computers, notebook, computer tablet, PCs, PD, pen-based tablets. Some version of these devices can be made with a more rugged, even wearable for use of the field. Many state agencies use electronic data collection for the bridge inspection, such as the see topic 310, detailed description of the hardware, software. Some state agencies are required using software. Special software packages can provide a comprehensive set of solutions, manage inspection, maintenance, repair bridges. They allow the user to maintain comprehensive set of an inventory database collected within inspection data within the electrical device, keep history of the inspection maintenance records, assign inspection maintenance requirements to each of the instructional component, automatically generate inspection reports, offer decision support. Alright, 345. Primary safety concerns. Proper inspection equipment can play a key role in maintaining safety for the traveling public and the inspectors. Inspectors do not have the right with the equipment. They may attempt to use the alternate piece of equipment that is not really designed for the job. This can only prove dangerous for inspectors, but used for public as well. The inspector should never try to substitute for the proper inspection equipment in the interest of saving the time of the money. The best way to avoid circumstances with the ensure this inspector have proper equipment for the job and the equipment is serviced and replaced periodically. This responsibility lies not only on the inspector but also the employer. It is important that the employer make every effort and properly equip all inspection teams. Also, inspectors should be familiar with every piece of equipment and how to use it and operate properly and safely. Alright, table of equipment, fundamental bridge inspection, method of access. Testing.